Hi there, this is homework number 1 in Quadratics. So this should be on page 3 of your homework packet. So at the top are some fill in the blanks just to make sure that you are reviewing your vocabulary and essential understanding. So quadratics. So the first one is the standard form of a quadratic equation is, and hopefully you can fill in that blank, but it is y equals, it's very strange. Y equals ax squared plus bx plus c. I color-coded it on the first page. The curve formed by a quadratic equation is called a, hopefully you got it, but it's called a parabola. Okay, the formula for the axis of symmetry is x equals that negative internal term over twice your leading coefficient. Okay. Now, if the vertex is the highest point on the graph, it is called a maximum. So that would be something like that. And if vertex is on the lowest point of the graph, it's called the minimum. So if I scroll now, or lift my sheet up, what we have to do is we have to find the axis of symmetry, the vertex. This is just like the class notes that we took the video of. Let's see if that's helpful to add a little light to it. I don't know. We'll see. And then we have to sketch a parabola. So let's go for it. So in my number 6, I have the y equals x squared plus 6x plus 4. So now I'm going to use the axis of symmetry formula. And I'm going to rewrite it. So x equals negative, well, what's my internal term? Well, it's positive 6, so negative 6 over twice my leading coefficient term. Now that equals negative 6 over 2, and if I take it all away, I should end up with negative 3. Now what I do is that I have x equals negative 3. Now I can plug it back into my original formula to get my y value. So y equals, well, negative 3 squared, again I'm just getting it from this original, plus 6, I'm getting it from there, and my original x, which was negative 3, plus 4. Okay, and let's start combining some of this stuff. So now I should have y equals 9, 2 negatives multiplied, minus 18 plus 4, and eventually I'm going to get that all of that equals negative 5. Okay. So the axis of symmetry was what I got over here. So axis of symmetry, this is such a weird shading thing. Is x equals negative 3. Okay, so that's where that axis of symmetry is, that line where I can kind of fold it in half, and the parabola will kind of fold up on itself. And then the vertex itself is going to be my x, y. So, and remember, x always goes first, and then we have our y, and I get my coordinate pair, that is the vertex, and that's going to be the lowest point. So if I were to sketch this, I could draw an axis of symmetry that would be at negative 3, right? And I could go ahead and plot a point here, which would be something like negative 3 comma negative 5. And if you think about where my actual axis would be, so it would be somewhere around here if I had my actual xy axis, right? And this would be, let's see, maybe negative 5, forgive me, negative 3 down, negative 3 to the left, and then negative 5 down. Okay, so that would be the actual point, the vertex. And then I could draw or sketch a very simple parabola, like something like that. Okay. Number 7. Okay, so again, we're just going to plug in some values here. If it does help, remember you can write something like A equals -2. You have your B that equals 8, if that helps you when you plug it into your axis of symmetry formula. But let's go ahead and it's kind of screwy. I don't know. I'm going to go ahead and fill in my formula. So right here for 7, I should have -8. Again, I'm getting it from here. Over 2 times -2. And if I keep going, I'm going to have -8. I'm going to have -4 on the bottom as a denominator. And when I divide them, rather, I'm going to have +2. So now I'm going to plug. So I'm going to rewrite my original. So I should have -2 times 2 squared plus 8 times 2. Again, because remember, x is equal to 2. I'm just plugging all of this into my original equation up there. -5. I'm going to square this first. So I get 2 squared, which is 4. 4 times -2 is -8 plus 16. -5, and I should have a y value of 3. So now let's look back at the axis of symmetry. I should have my x equals 2 up here. I should have my vertex is really my, if you think about it, it's kind of like my solution, at least to find out what that highest or lowest point is. So it's a point of my parabola. And if I have a sketch here, again here, to give you a little context, I'll do my x and y. And let's see, if I have a vertex of 2, 3, so I'm going to go maybe over 1, 2, 3, something like that. That should be 2, 3. And then remember, it's a negative. Remember what we said earlier, if it's a negative leading coefficient, it's going to open down like a frown. So I know this is going to go down. It's going to go something like this, okay? And I'm going to draw that line, that axis of symmetry line. And that should be x equals 2 down here, okay? So that's a frowny face. Okay, going on to number 8. Okay, so let's look at our A and our B value. So our A value is, let's see, 1. My B value, which is my middle term because I don't have a constant here, is -2. So here I have x equals, so negative of the -2. Be careful of that because remember, the original formula is x equals -b over 2a. So if I have a negative number, hopefully you know what that means. I have a positive. Anyway, so my denominator is going to be, remember, my 2 times a, so 2 times 1. A lot of times you're going to see a denominator like that. If you have no leading coefficient, it's just going to be 2. I'm going to end up with 2 over 2, and I'm going to end up with 1. So I'm going to go ahead and I have my x equals 1. So I already know my axis of symmetry. So I can even go ahead if I wanted to put a little coordinate plane on here, and x equals 1. Well, I could go over here to like 1. And I know that that's going to be where that line of symmetry is. Okay. But let's go ahead and because we want to get the other side, we want to get the y. So I'm going to plug in my x is 1 back into my formula. And I'm going to end up with y equals 1 squared from here minus 2. And then remember, x is 1. And I want to keep solving that. I should have y equals 1 minus 2, which equals -1. So now I have a vertex. So my vertex over here is going to be 1, -1. Okay. So if my x, this was my, again, my line of symmetry, but now I'm going to find out where my vertex is. So if I go over 1 and down 1, that is actually my vertex. And going back here, our leading coefficient was positive, so which means we're happy. So it's going to be something like that. Okay. Let's go ahead to number 9. And let me move this. It is starting to snow, and I'm getting a little bit over this snow, I have to be honest. As much as I love Colorado, kind of done with, oh dear, with all of my snow. Okay, something got a little funky here. I think I lost something. Oh, yeah. Sorry. Okay. That's kind of annoying though. I don't know what happened. Okay, so if I look at number 9, see, it's going to be annoying because I'm going to, I don't like that. Give me a minute. Sorry. Just forgive me for just a moment as I prop my stuff up again. Sorry. That is so not working. That's really funny. Anyway, I give up. Okay, so let's just look at this one. So if I have my x equals negative b over 2a. Now, let's go for it. Over here, I should have, I'm going to plug in some values. So I have my axis of symmetry formula. So x equals negative, remember, negative 8. I get it from there. Over 2 times my negative 1 right here. And then if I multiply this out, I should get 8 over negative 2. Now, and when I divide that out, I should end up with negative 4. So if I go over here to my axis of symmetry, that means x equals negative 4. So now I am going to plug in, I got x is negative 4 over here. I'm going to plug it in to see what my y is going to be. So y equals negative, watch out for that, negative 4 squared minus 8. Multiply that by negative 4. So I've got lots of signage issues or potential problems here, right? Okay, when I take it a step further, I'm going to square negative 4. So negative 4 or just 4 squared is still going to be 16. But now I have a negative sign, or negative 1 that I would really distribute over it. So it's going to be negative 16. Got negative times a negative. I'm going to end up with positive 32 minus 9. And I'm going to end up with adding them, combining, I'm going to end up with 7. So y equals 7. So if I go back over here, my vertex is going to be negative 4 was my x value, and 7 was my y value. Now I'm going to sketch it. So I have my x and my y, my coordinate plane here. And I'm going to think about, let's just go for the vertex. Let's do that first. Well, let's see if my x is 1, 2, 3, 4, like somewhere around there. And I'm going to go up 7. So I'm going to end up with something like that as my vertex. Now, remember, this is a negative, which means a negative coefficient, which means it's going to be a little sad. So I'm going to end up with something kind of like this. There's my axis of symmetry, and I could even write x equals negative 4, and this point up here I could identify as negative 4 comma 7. Okay, so I'm going to scroll to the back. Okay, and here we go. Let's look at number 10 together. So I like to keep writing that x equals negative b over 2a. I think that's right. Hopefully you can check, see if I'm right. And now I'm going to do x equals negative, well, 0, if you think about it, which is totally wrong. I was looking at the wrong one, sorry. Negative, let me try that again, negative 20 over, well, I have 2 times a, which is negative 5. So I'm going to put that in parentheses. Okay, so I have a negative 20, which basically negative times negative is a positive. So I'm going to end up with positive 20 over negative 10, which equals negative 2. And you know what I'm going to do? I'm just going to keep going for it. So if x is negative 2, let's go ahead and plug. So now I have negative 5, which is my a value here. I have in parentheses negative 2, which I'm getting from there, squared, because I'm just plugging in my x into the original equation. Minus 20 I get from there, and then again another x, which is negative 2, minus 26. Now I'm going to keep going. So I have 2 times 2 is 4. Remember, it doesn't matter if it's an even exponent, it's still going to be positive, so I should have 4 times negative 5, which is negative 20, plus 40, minus 26, which when I combine all that, I'm going to get negative 6. Okay, so that tells me lots of things. So my axis of symmetry, if I go over here, my axis of symmetry is going to be x is equal to negative 2. And my vertex is my x, remember, and my y values together. Okay, and remember my original coefficient was negative. If it's a negative coefficient for my a value, remember that means I'm going to go down. I'm going to be a little bit sad. So let's see, I have my x, I have my y, I have x1, 2, that's like negative 2. And now I'm going to go down negative 6, so pretend about there. Okay, so this is going to be my vertex point here. And I, unfortunately, well, you'll get this, you'll still get the drift, but this is going to be a negative 2, negative 6, and that's the top. So I'm going to have a graph that looks something like that. And on my axis of symmetry, something like that. Okay. Moving on to number 11. I'm going to keep writing it, this formula. It's really fun to keep writing. Okay, hopefully we can get a little faster here. So now x equals negative 0. And we have over 2. And hopefully you see why I wrote 0 here. Is there a b value? This is actually your c. That's not a linear, this is a constant. So could I rewrite this? I just want to show you something like x squared plus 0x, if you think about it, minus 4. That means the same thing. So don't get this confused with that as a b value, because this is your c. Okay. Anyway, going back here. Now I have 2 times 1. So now I should have, 0 divided by, well, anything is 0. So x is 0. Now when I plug it back in here, I should have, well, 0 squared minus 4. So, and what I get is negative 4. So I have x is 0, y is negative 4. My axis of symmetry is x equals 0, and my vertex is 0, negative 4. So now I can go ahead and I can graph this. And going back here, my a is positive, so I think that means we're happy. So if we're happy, the parabola is going to smile at us. So if I have got my x, I've got my y, I'm going to end up with 0 here. I'm going to go down 4. 1, 2, 3, 4. And this is going to be my vertex. This is 0 here. 0 and down 4. I'm going to end up with 0 and negative 4. And then I'm going to smile up. And guess what that's very interesting because my line of symmetry is really the what? It's actually the y-axis, which is kind of interesting. Where x is 0. That's kind of cool. Okay. Whoa. Okay, number 12. So x equals negative b over 2a. And again, keep rewriting that. And now I have x equals negative 2. And on the bottom, I should have 2 times negative 1. Because 2, right? I can already tell, look, I'm actually going to go ahead and do that right now. My parabola is going to go down because this is negative. From here, I have negative 2. Over negative 2, which is 1. So my axis of symmetry is x equals 1. Okay. Back here, I'm going to go ahead and substitute for 12. I'm going to have a negative, and then I have 1 squared plus 2 times 1 minus 4. Plugging in from there. And I'm going to keep solving here. I have negative 1 plus 2 minus 4 equals negative 3. So y equals negative 3. So now I'm going to write that as a coordinate pair as my vertex. So remember I have x equals 1, and we just solved for y, and x is negative 3. So here is my little sketch. I have got my x, I've got my y. See how scientific this is. If I look at my vertex, my x is going to be at 1, then I'm going to go down 3. So it's going to be somewhere around there. And I'm going to write x equals 1. So this is my line of symmetry. And this is my vertex. Oh, no, and it's really sad, right? Because it's negative. So I'm going to end up, I should do it more like that. My parabola is going to face down like that. Okay, number 13. X equals negative b over 2a. So do you think I need to rewrite this in the right form? I could. I'll just show you. Well, this still means, right, negative 3x squared plus 0x plus 0, if you think about it that way. Sometimes it's helpful to write it out like that. And let's see, let's go for it. So now I should have x equals, well, negative 0, because b is 0. And I have 2 times a, so I have negative 3. So it looks like I have 0, and it doesn't even matter. If I have any 0 in any part of the top, then the whole thing is just 0. Remember, if you have a 0 down here, it's just undefined. Because if you didn't have a 0 for this quadratic, it wouldn't even make it a quadratic, because it would be 0. Hope you caught that. But okay, so I'm going to plug in 0 for x, and I'm going to end up with y is negative 3 times, 0 squared, right? So y equals, well, everything gets annihilated there, 0. Okay, so the axis of symmetry is x equals 0. And my vertex is, well, 0, 0. That's what we got for both. But if I draw this out, and remember my coefficient, my lead quadratic coefficient is negative 3. It's pretty negative, I'm sorry to say. And this is the origin, my 0, 0. That's actually where my vertex is going to be. And it's going down. I'm going to go down like that. And I'm going to have that axis of symmetry right here. Okay. 14, we're almost through. X equals negative b over 2a. 14. Okay. I have x equals negative 12, remember from right there, okay, over 2 times my a, which is 2. And let's see, negative times negative 12 is 12. 2 times 2 is 4, and that's kind of a nice, neat number. So I have x is 3. I'm going to write that over here as x is equal to 3, if you can see that. And then I'm going to go back here, and I'm going to plug in my 3, and I shall end up with 2 times 3 squared minus 12 times 3 plus 10. Y equals, what 3 squared is 9. 9 times 2 is 18. Minus 36 plus 10 equals negative 8. So over here, I'm going to plug that back into 3 comma negative 8. And I'm going to go ahead and graph that. Here is my coordinate plane. And I have to look back at my leading coefficient, which is it positive or negative? Well, it is positive, so my parabola is going to go up. So let's go ahead and plot our vertex. So the bottom point is going to be at, if I count over 3, and then go down about 8. That's going to be where my vertex is. There's my parabola. There is my axis of symmetry at x equals 3. And then here's my coordinate point. And voila. Okay, down to our last one, number 15, last but not least. So I have x equals negative b over 2a is my formula for the axis of symmetry. I'm now going to plug in some values. Equals, I have 1, I have 10, I have 24. Okay, so negative b, okay, so it has negative 10, and I have 2 times a, so 2 times 1 is 2. So I have negative 10 over 2, which equal to negative 5. I'm going to plug in my negative 5 to get y equals negative 5 squared plus 10 times negative 5 plus 24. Negative 5 squared is 25 plus 10 times negative 5 is negative 50. Plus 24, and when I combine them all together, I should get y equals negative 1. So now I have a coordinate pair. I have my vertex, I have my axis of symmetry. The axis of symmetry is x is negative 5, and my vertex is going to be my x and my y. So let's sketch it out, and then we are done. So first of all, if I go back to my original equation, it looks like I have a positive coefficient, so this parabola will open up. And let's go ahead and look for my vertex, which is x is about negative 5, and then down 1. So here's where our point's going to be about. That's going to be our vertex at negative 5, negative 1. And there is going to be my axis of symmetry, and there is my parabola opening up to the world and rejoicing. X is negative 5. And there you go. I wish you luck, and I hope it went well.